Okay, it looks like the stream is up. Let me quickly just have a look here at the side to make sure that everything is going. Starting the show a bit early today just to make sure that we don't have the same technical issues that I had last time. So let's check that. Let's double check screen switch. That's working. Audio check. I don't need my headphones this time. And I do believe we are good to go. So I'm going to be sitting here sipping my tea because I've already had, I think, 4 cups of coffee this morning. And till we wait for it to hit the hour before we kick things off today, if you are here yet already. For those joining, let me have a look. No comments yet. Yeah, everything seems to be good. Let's see. I see my first viewer. Welcome. I see there's someone watching on YouTube. This is a session that we are going to be kicking off in about a minute on the hour. This is a series called Developers Let's Code. And today we are going to be starting from scratch with containers. And I'll be taking you through information around how to get started with containers. And then we'll be building out an Elastic Beanstalk application that uses containers. Hey, Ahmed. Let me just make sure everything is set up. Yeah, today is not a mad dash as it was last week. That was a little bit of a last-minute panic. Cool. So for those who have joined, I'm just quickly waiting for, well, not the noon gun, the 10 past noon gun, or the 1 o'clock noon gun to kick off the session. So a couple last sips of my tea just before it gets cold. There we go. Cool. We are now live on the hour. Cool. Awesome. So welcome everyone to this episode of Developers Let's Code. This coding series is focused on developers new to AWS and just starting their journey on building services on AWS. So the whole purpose is to go step by step and show you specific ways of building. And for today's session, we are actually focusing on containers. So let me quickly update my banner just to confirm that. Let's do it like this. Oh, sorry. Screen sharing keyboard is a little bit funky sometimes, so let's do that. Containers, enter, boom, there we go. So, welcome. Like I said, today we are going to be focusing on containers. So we're going to take the entire hour to look at how can we easily deploy a containerized service. So, overview first. When we think of containers, we first have to cover exactly what is a container, and then also there's some different standards, what is Docker, etc. So let's kick off with that. And also, please, as we go along, I will be keeping an eye here on the left to comments. The idea is that I'm here to help you and show you how to build things and how to learn. So if you have any questions, please send me the question to me and stop me as we go along. Cool. Just one more thing. I need to mute myself, I think. There we go. Otherwise, okay, there we go. I'm hearing myself and it confuses me. So what are we doing? We are building with containers. So let's start off with what is a container, what's an image, what is a Docker, well, what is Docker itself? So containers are a mechanism that you can take your application code and then package it with the dependencies to run it inside effectively it's a zipped file. And then what you do is you can take that container and then run it anywhere. So let's say I build my container locally. I can then take it, run it here, and then also send it to other locations and run that. Apologies, Lawrence. This session today is not focused on anything other than containers. We're not going to be taking a look at anything else. So what we want to do with containers is have the ability to actually ship our application easily. And why containers have become so popular is that they allow you to put pretty much anything inside that box and then move it around without knowing what is inside the box. So think of it this way. Let's say you're writing an application in Java. If you want to deploy it on a specific server, you need to have some kind of Java runtime installed there specific to the version that you want to run your code on. There's normally backward compatibility, so you could, for example, if you compile your code with Java 1.60 and you run it on a JRE of 1.61, that normally should work. But preferably, you want to be running on the version of the runtime that you actually built your application. So the challenge here is, let's say you've got a server and it's running 5 or 10 different applications, all of them on Java, all of them on different versions of Java. You will have to have many different runtimes installed on the server. And then if you want to run your application, there's quite a bit of configuration required to make sure that your application uses the correct runtime at that point. So what Docker does is, by installing this dependency inside the same zip and creating this isolated environment for your application to run, it means that everything is packaged with your code in terms of what it needs to run, and you just run that container on your server. And the server itself doesn't have to have Java installed. It only needs a Docker installed. Just quickly, I'm having a look here at the comments. Cool. So just quickly on the questions here. Firstly, let me pop the one on the screen. We've got a question around using Git, Jenkins, and Docker, something similar on AWS and code pipeline. So what we're going to be doing today is I'm going to be showing you how to deploy a container using AWS Elastic Beanstalk. And part of that will also be to show you how to set up a CI/CD pipeline. So we're going to go and actually set that up. So second question here. If you're writing an application in C# and want to run it under Mono, my recommendation there, Stewart, would be that take a look at .NET Core. You can actually run .NET on Linux now, as well as other operating systems. So I would rather spend time on that than on trying to get C# running under Linux at this point in time. But please keep the questions coming. So we've quickly covered what is Docker, which is this container that allows us to actually deploy. And just quickly, Docker is one implementation of the container standards. There are other implementations as well, like Rocket, which is spelled RKT, etc. So it's not just that there's only this one standard, although Docker is the most prevalent one you'll see in the market. So also just quickly to clarify, you might have heard of services like Kubernetes, Rancher, the old Mesos Marathon, which is now called DI2, I believe. I can't remember exactly what they renamed to, the old Mesosphere. You might have heard of Amazon's ECS and EKS. So the difference between Docker and all of these other frameworks or services that I just mentioned is that those are orchestration frameworks. And what we mean by orchestration framework is this is something that takes the responsibility of deploying your container, keeping it running, scaling it, sending it configs, making sure it's healthy, etc. Where Docker itself is only the standard to create these containers that you want to ship. So the difference is, for example, the other services would take that container and make sure that it's running, and that's how your service is then exposed to the world in all the different ways. And what we're going to be doing today, again, is we're going to use Amazon's or AWS Elastic Beanstalk to actually get that running. So what we're going to do is we are going to start off by creating an Elastic Beanstalk environment. So for that, I'm going to head over to the Elastic Beanstalk part of the console. And what we can do over here is you can see we don't have anything running. And now what you'll see on the left here is, firstly, there are two sections here. There's the environment and there's the application. So we are going to start off by creating an application. So this is the app that you want to deploy. And one app can have many environments, because typically you would want to be able to deploy your application to, for example, dev, and then also to production. And then what you'll do is you'll make changes to dev until you're happy with it, and then roll them forward to production, or automatically deploy to dev first, run some tests, then deploy to production. Depends on what you want to do. So for today, we are going to create a single environment as well as a single application. So let's go ahead and get started with that. So let's start with the application first. Let's just get rid of that. And our application is going to be let's code containers. And here we can add some tags to it. Now, tags are a way to identify resources to be able to identify it. So, for example, you can tag and call it, let's say, environment like this, and we can call it dev. And I can add that tag, for example. And now we're going to get to the platform in terms of what it's going to run on. Just quickly to answer Stuart's question around that I don't need an EC2 instance, just a container. So with Elastic Beanstalk, you do actually have an EC2 container in the background running your container, but you don't manage it. You can get into it and do things to it, but you don't have to manage it. Elastic Beanstalk takes care of that. If you're looking to go completely hostless, you can look at AWS Fargate. That allows you to actually deploy a container without having to configure, host anything. You just say CPU, RAM, number of copies, and AWS Fargate will take care of that for you. So getting back to our Elastic Beanstalk environment. Now the platform is what we want to deploy on. So, what we want to deploy. Now Elastic Beanstalk can do containers as well as a host of other ways of running your app. So if we look at the first ones over here, we can see that we have got Glassfish, which is a web server that you can use to deploy applications to. Then also we've got language-specific ones that you can see down here, Go, Java, Node.js, etc. So you can actually have a Elastic Beanstalk project, and it has 1 or 2 files that you have to add to tell it how to build the project, what files to use, etc. And then we can actually compile and deploy that directly on the EC2 host for you. But for what we want to do today is we're going to be using Docker. And just quickly, Stuart, what you can see over here is that you can, for example, if you didn't want to use Docker for your C# project, you can use .NET Core directly on Linux, and that'll allow you to deploy that C# project if it was built with .NET Core directly on the host without having to worry about the complexity. Or you can wrap your C# application inside a container and use this Docker deployment that I'll be showing you today. So we're going to be picking Docker. Now we're going to stick with all the defaults here. So we're going to be using Docker running on 64-bit Linux too. But you can see over here, we can also pick running multiple container Dockers on Amazon Linux. Now, part of the file that we'll be creating later is whether you want to run one or more than one container. And we'll get to that in the actual deployment file that we'll be creating. So what we want to do over here is that we have to pick between our application code. So we can use a sample, or we can upload our code. So let's go ahead and say upload our code. So what we have to do is we'll be doing a, oh, apologies, I forgot to share my screen. No wonder. There we go. There we go. Okay, thank you. Cool. So there we go. So sorry, let me just do this all again. We're going to get started from the scratch. So we're going to say create application, and we are going to give it a name called let's code like this. And we can tag it, for example, with a name. Sorry, not name is reserved because we already have that tag. Let's call it environment, and we're going to call this dev. The platform that we're going to choose, sorry, now this is where you can see this list. Apologies for not sharing this earlier, is where you can see, for example, we're going to be picking Docker, but you could pick the different languages, or Glassfish or Tomcat as web servers, or even run .NET Core directly on Linux. But for us, we're picking Docker. And over here, we're going to stick with the defaults of the Docker running on 64-bit Amazon Linux 2, and also platform version 3.1. Now, for our application over here, we're going to say, actually, let's just start with the sample code, because that's the easiest way to get this up, and then I'll connect our pipeline and we can replace. This is completely live. Goof off 109. Guru Catherall has a question around EBS under 3-tier architecture. That is a slightly different question regarding how EBS is the storage volume that you attach to your virtual machines called EC2 host. And for 3-tier architecture, it depends on what kind of load you're running to figure out how many servers you have got or you'll need. Today's session is going to be focusing on getting a container up and running using Elastic Beanstalk. So that's currently what I'm busy setting up. I'm busy building out the Elastic Beanstalk environment. Cool. So let's go ahead and say create our application. So now what will happen here is that it is now in the background figuring out all the infrastructure that we need to do this. And from our perspective, we don't have to worry about setting up all of this. It also takes care of creating an IP or an Elastic IP that actually is attached to our EC2 instance. And then it points, oh, sorry, EBS, Elastic Beanstalk, not EBS volume. So we will get to the scaling at some point. Sorry, I misunderstood the EBS term there, Guru Catherall. The number of EBS ones, I will show you that there are actually some auto scaling options where we can decide how to automatically scale our environment. And we are going to go from a single environment up to multiple environments. So what we're doing now is we're just busy creating our environment, and this will take a minute or two for us to spin up. So I'm quickly going to grab a sip of water while this just spins up. It normally takes about 2-3 minutes. So if we have any more questions, you can throw them my way so long. We'll have a look. Let's see. Yes. So Goofoff says it depends on the metrics that you set for horizontal and vertical auto scaling. So for today's session, we're actually only going to be looking at horizontal scaling. So just quickly to clarify that term for those that aren't familiar with it, horizontal scaling is where you take, let's say you've got one instance and then you start spinning multiple ones next to it. So you're scaling out sideways by adding more nodes to the cluster and distributing loads across those different nodes. Vertical scaling is where you start saying, listen, make the instance that this is running on bigger. Hello, Not Quiz. Welcome. Darko, my bearded brother in another country, is here. And what vertical scaling does is, so let's say I'm running on an instance with 2 CPUs and 4 gigs of memory, and I see that's not enough for my service to keep handling the load. I would go to something bigger. So I might go up to 4 CPUs and 8 gigs of RAM. And the challenge with vertical scaling is that at some point you hit a limit. You can only go so big. Granted, that is quite big nowadays. The largest servers with regard to memory that I've seen have up to, I think I've seen instances with 24 or 36 terabytes of RAM. And CPU-wise, I have been on a system with, I want to say 266 cores or 272 cores, which excluded hyperthreading. So you can go quite big. But yeah, so getting back to our application and what we are doing today, we are spinning up a Docker container and we're using Elastic Beanstalk to do that. So what we've done now is we are busy creating our Elastic Beanstalk environment. So while this is going, let's have a look over here. We've already created a load balancer. This is interesting. So by default, the sample application looks like it's going to be distributed across multiple nodes. So what I'll do is I'll scale that down to 1 just to show the difference. And then in the end, we're going to scale up to 2 again. So let's have a look over here. We can see that now if I go back, my environment over here is in its pending state. So let's go ahead and click over here. And now it's busy loading. And what we can see is that 1 instance is coming up. So just quickly to show you that we are just running on normal EC2 instances, I can actually open up the console. And what we see over here is the EC2 portion of the console. And we can see running instances. If I open this up, let's just take this away. We can see, so the first 2 over here are Cloud9 virtual environments that I'm using. So over here, when you see this is a web-based IDE inside your AWS account. The service is called Cloud9. We're going to be using this to interface with the various services. So this just runs on an EC2 instance, which is currently this one over here that we're using. Now, the environment that we just spun up is this one. So you can see that it's in the process of initializing. It's a T2 micro, and it is busy spinning up. So let's go back to our Elastic Beanstalk environment over here. And, oh, there was some more information. Cool. So we have successfully launched our Let's Code environment. So let's go have a look and click on this environment now. And awesome, we can see actually that it's okay, it's up and running. And let's go ahead and open up the web page and see what it actually launched. Sorry, I have to click over there. So we have got an Elastic Beanstalk, a container up and running. And it appears that everything is happy. And we can see over here that it has launched with the Elastic Beanstalk Docker platform. Great. So we're in good shape. We're now at a point where we've got something up and running. It's not running on HTTPS. So if I look over here, we can see not secure. You can't see that drop down. Sorry about that. But you can see that the URL firstly doesn't have HTTPS in the front. It's just HTTP. And also, it's not really a useful URL. You can see that it's let's code-env.eba- bunch of letters with a lot of suffixes. So this isn't useful. So what we're going to do now is we're going to slowly work through making this better and making it easier to actually get our application in a more usable state. So what is the first thing we have to do? Well, I would say we probably want to be able to launch our own code. That's normally a good place to start. So how do we do that? Well, let us go set up a code repository first. So sorry, we're going to jump over here. I am going to go to, I think this is, no, this is certificate manager. Apologies. I actually use the icons up here instead of the text because it doesn't all fit on the screen and I don't know all the icons off by heart. But here we go. We have got code commit. Now, code commit is a Git-based repository that you can create inside your account. So we're going to start off with that. So quick question from Stuart. What would I use to share some state between big multi-dimensional array between all instances? Depending on the size, if I have to share it between all of them, I would look at something like a caching mechanism, so Memcache or Redis, and you can use that by making use of AWS Elastic Cache as a service that actually gives you managed versions of that. Cool, but getting back to this. So what we want to do is we first need to create a repository for our code. So let's call this repository, let's code. As you can see, I've done this before. And then we can say repo used for the demo during let's code for containers. Cool. And we're not going to enable Amazon Code Guru, which is a reviewing tool. And we are just going to go ahead and say create. Now, what you can see over here is that it actually gives us a couple of ways to access the repository. First, just on HTTPS means that we can just download the files. We can't upload easily. But what I want to do is I'm going to use SSH access to do that. And what you can see over here is that we will be using Linux because this EC2 instance that is hosting our Cloud9 environment is EC2. And what I can show you here is that these are the steps to actually set everything up. So I've already done this. The important part over here is that you need to generate an SSH key, and then you need to attach it to the IAM user inside your account. And then once you've done that, you need to create this file in your local SSH directory. So if we go over here quickly, what I can show you is if I go cat.sh config, I've actually created this, and you can see over here, these are the details. And that's fine. I'll delete this user after this session. And there's no private information here, so we are still good to go for now. Cool. So we have that set up. Now the next part is that we have got this repo, and now we need to actually get some files in there. So let's start off by actually cloning it. And what I'm going to be doing is, and just let's move this, let's encode one to, sorry, let's code EBS. Cool. Because I now am cloning this repo with the exact same name. So let's do that. We're cloning it into this repo. And just wait for it to finish quickly. There we go. I've cloned an empty repository, which kind of makes sense. So what are we going to be doing? Let's go into our repository. Cool. And then first thing I'm going to do is I'm going to move the README that I created previously. What did I call that? 3 dots, that's why it's not working. Let's encode, and I want to move the README here. Cool. Let's quickly close this file and open up my README that I have. So this is just a basic README, nothing fancy about it. So I'm going to go ahead and add this to our repo. So git add README, git commit message, adding a README file. Cool. Yeah, so just quickly, Guru Thurible, the architecture for today is going to be a very simple single tier application because we want to go through how to get an Elastic Beanstalk application up and running. Now, you can extend this because Elastic Beanstalk actually is able to run multiple containers. So you can very easily set up a second container as your backend and have a database, and then the front end. So you typical 3-tier architecture. But for today, the focus is just on how do we get our CI/CD pipeline set up, and then also how do we use that to deploy our own custom container. So that is what we are focusing on for today. So we now have a repository. We just added a file, and we, as you can see, Git is not configured on this one. So let's quickly do that. So just to make the commits look good. So we paste that. My name is Quibus Bernard. Actually, I forgot to introduce myself, but that's fine. I will do that in a sec, and let's paste that in there. Cool. And now what we do is we amend our commit quickly. Oh, it's probably going to complain because Nano is not installed. Sudo apt get install Nano, which is a text editor. There we go. Nano is already in the newest version. Let's just run this again. Please, let's just do that. Mem amending author. There we go. Now let's push. So Git pushes the code into our service. So quickly, are we using everything native or? Yeah, we are going to be pushing our Dockerfile. We don't have one yet. We will be building one from scratch, and I will show you my very non-elite HTML skills as well. So Yes, I am from South Africa. Did the accent give it away? I'm actually based in Cape Town. So maybe quickly let me introduce myself. My name is Quiz Bernard, and I'm a senior developer advocate for Sub-Saharan Africa, and I'm based out of Cape Town in South Africa. So it's currently winter this side, other side of the globe for most people that tend to join the stream. And today we're going to be focusing on how to get a container up and running using Amazon or AWS Elastic Beanstalk. So we just pushed this file. So let's see if we can see it inside our environment, inside our code repository. So let's go back to our code over here. And when it loads, what we'll see is that we actually have a README in here now. And we can actually see the content of the README. So yay, we are good to go. We actually have a repository and it's busy working. So now the next step will be to, get our container up and running. So for that, what we're going to be doing is we're going to be creating a Docker file. So let's go ahead and say Dockerfile like that. And for this Docker file, what I'm going to be doing is I'm going to be creating from an Nginx one. And what I want to do is that I want to just copy the file from a local file. So let's quickly just do that. Make the website and then touch website index.html. Cool, and we will get to that. And now what we're going to be doing is we're going to say copy website slash index.html, and we're going to be copying it to somewhere inside the container. Now for this, let's quickly take a look at what the container has in it. So I'm going to look for Docker Hub Nginx, and let's see what it says. So I'm going to be using some public containers. And just make it easier so people can understand what we are busy building. So what we can see over here is that we've got a whole bunch of different ones. And we're going to scroll down to see where we can actually mount that file. So what we have over here is, that is, I believe, where we want to copy that file to. So sorry about that. Let's copy the file to there. And that is all we need for this, except we need to obviously put some HTML in here. Now, this is where things are going to get really rough because my HTML is very, very bad. So I'm literally going to Google for sample HTML file. I'm primarily a backend developer and DevOps and automation and infrastructure. So also, hi. Oh, goof off, you're an insomniac from Texas. Awesome. We're in Texas. I actually spent some time in Austin a couple of years back on a project. Really enjoyed it there. So let's see if we can get a basic document here. Oh, this is way too much information for me. HTML document. This looks like a good start. So let's grab all of this and let's put it in here. Right. Now the heading, we'll call this let's code. And let's just say our awesome application. Right. Cool. We've got our first awesome application. Now, in theory, we should be able to build a Docker file. So let's go ahead and see if we can do that. So it's docker build -t dot. Now, what this does is that the build command instructs Docker to actually build a container. The -t tells it to tag it, I believe, and then the dot says in which directory. So by default, Docker will look for a file called Dockerfile with a capital D. So let's go ahead and build this and see what it happens. Actually, just Docker, -t is if you want to tag it with a specific version. So we're just going to go with the Docker build for now. You'll see in a bit that we actually copy and paste it, which is why we don't have to worry about it. Cool. Okay, so there we go. Now remember, -t, and we call it let's code. That is why we want this. So now we've got it tagged. So now what we can do is we can say Docker run interactive and terminal, and we want to say let's code, and we want to make sure that we can actually run our container. Let's see quickly. It seems to be up and running, and now what I can actually do is I can preview running application over here, and what it says is an oops, no application seems to be running. Let's just make sure that, and the reason for that is ports, and this is where things start getting interesting with Docker. So you've got your application running inside a container. that container might have something running inside it on a specific port, let's say port 80 in our case, because it's an Nginx web server. Now, the container itself, unless I give it a specific command, that port is only open inside that container, nowhere else. We can't access it. So what I need to do to be able to do that is one of two things. I can either do port mapping, which means I go -p and I say port 80, 80 and :80 like this, which means it'll map the container's port 80 to the host's port 80. So we do that. Okay, port 80 is already in use. That is not nice, so let's change that to, let's mark it port 8080. Because it seems there's something to be running there already. Cool. So now what we can do over here is that if I go to the end of this, so I've said on my local instance over here on port 8080, I've got my container running. And now if I open this up, oh wow, we can actually see our application. So we now have got a very advanced application up and running. So Guru, yes, you can actually launch a Java application using Elastic Beanstalk in one of two ways. You can actually make use of containers like we are and wrap your entire application in a container and deploy that. Or there's a way that we are selected Docker. You can also select Java there. We'll ask you a couple of questions of what version of Java you want to run, and then you would have to add a file to your Java repository to describe the Elastic Beanstalk application to actually have Elastic Beanstalk deployed for you. But let's continue with our container. So we now have a container. Great. It's running on my local machine. Great. Now the next step is, how do I get this somewhere else? Well, for that, what we need is we need to be able to push this image that we've just built for our container. And just quickly, the difference between an image and a container is that I've got a Docker file that defines how I want to build this image. The image is the actual zip file of what it is I want to run. As soon as I take that image and put it into a running state and actually use it to create a container, it becomes a container. So that's just the difference between a container and a image. Quick question, is Elastic Beanstalk good for Spring Boot? Spring Boot uses Java. Elastic Beanstalk can run Java applications, can also run containers. So yes, you can definitely run your Spring Boot applications on Elastic Beanstalk. Cool. So now the next challenge, so let's quickly shut down our container VM. Because we have it running locally, we now want to be able to get this container somewhere else, which means we need to put it somewhere so that we can get hold of the container. So for that, what we are going to do is we are going to create a Docker repository for us. And in this case, what we're going to be using is, I think it's this one. Let's see if my icons are, nope. This is actually quite fun. Let's quickly cheat and put on the text. I don't think I have it on here. Icons only. Cool. Regardless, what I can do is I can just click over here and I can say ECR and Elastic Container Registry. And we pop that up in a new window. Sure, you want to see the Docker file again? While we go there, it is extremely simple. We're literally saying from Nginx, which is the base one container that we're building from on top of each other. So how Docker works is this from command says that I want to start building on top of someone else's container and just add steps to it. So at the very bottom, there's a container called Scratch, which is literally an empty tar file. It has nothing inside it. Then, for example, if I want to start using a container with that, let's say, has Ubuntu in it as the base operating system, then you'll go and install the actual OS in there and get all the files ready. And that will then, for example, be known as the Ubuntu container. And then I can go say from Ubuntu and then add additional things using what was installed there previously. So example, let's say I want to install Nginx. I can go apt-get install Nginx because apt-get, the binary is already in that container because of the fact that we prepared the Ubuntu container. Then you can also, just quickly on containers, you can specify a tag. Now, normally, if you don't specify one, it grabs latest like this, which is the default tag. But you could also grab specific versions. So let's say there's an Nginx version 1.2.3. That's just a string tag, and I'll now grab that specific version. So I can, when I version my containers, I can easily say launch version 1, 2, or 3, and actually jump between them. But once again, for today, we're keeping it simple, and we will not go into the tags too much. Getting back to that repository that we want to spin up. We already have one over here. Let me quickly delete it. I did do a test beforehand, luckily. And what we want to do is we want to say create a repository. Let's give it a name. Let's code. And over here, you've got two options to select. The first one is tag immutability. So those tags that I just spoke about, if you enable this, if I create a latest container, and I push it to this repository, or I tag it with latest, and then I build a second version and tag that with latest as well and try and push it, I will get an error. The reason this is important is that if you keep, for example, changing the code and you keep tagging it with latest, when you do deployments, you're just going to see latest. You're not going to know what version is running. But also what happens, let's say I've got one copy running with whatever latest is that I built yesterday. Now I do a code change today and I build that one and I push it and I tag it with latest. Now I've got a scaling event and I say I want a second container. I bring up a second one. This latest doesn't match this latest. So now I've got two different copies running in production. And this is why you would want to tag immutability. But for today, we're not going to enable that. The second setting over here is image scan settings. And this is important because, as you know, we get CVEs, which are, I can't remember what CVEs and vulnerabilities effectively. It's a way to let people know that a specific package with a specific version has got a specific vulnerability. So for example, package A, if you do a call with this weirdly formed packet, you can run code on it, etc. So by enabling image scan, it'll actually give us an overview of how many vulnerabilities that it finds inside our container, and also what's the severity of them. So is it just an informational one, or is it a critical one and you really need to patch it as soon as possible? Then lastly, you can actually encrypt your containers or images at rest. We're not going to enable that today. So we are going to say create our repository. Okay, quick question. Difference between Docker Hub and ECR. So both of them are Docker image repositories. So you can push your images to them and store them there. The difference is that Docker Hub is public and ECR is actually a service inside your AWS account. And also, you can use different people's ECR. There are public images and private images. You can use other people's ECR. There are a lot of customers actually running Elastic Beanstalk production environments and with a lot of success. So it entirely depends on what you're building and how complex you want to go. So getting back to our ECR repo over here, what we have is a repository. And if I click on it, we can see that we don't have any images in here at the moment. And if I click here at the top, you can see there's this handy view push command. Now, this is the information that we need to be able to actually get our container that we just built on that Code9 environment and get it into this repository. So the first step always is this login command. Because ECR is a private repository inside your AWS account, you need to log in because it still uses Docker, and Docker needs a username and password. So this command is just an AWS CLI command that generates a temporary username and password that expires after a certain time, and then sets those values in a JSON file that Docker knows where to read to actually then be able to authenticate and push the container. So let us go and just paste that command, and we hit enter and we run it. And what we can see over here is a warning that says your password will be stored unencrypted inside that specific JSON file. Now, this is because this is our secure instance. This is fine because Docker uses that JSON file to store username and password. So that's how it actually accesses it. So now we're logged in. So next step is we need to create or push our Docker image that we just built. And to do that, if we go back to ECR over here, we can see that this is the command to build that we just did. But now what we need to do is we also need to tag this container with an additional tag, because the tag also determines where you are pushing the container to. So let's go back and we just once again paste that command because we've just built our container and now we're pushing it. So now it's been tagged. And now the last step to get it inside our repository is to push it. So let's copy that command. And this is by default on any ECR repo that you create. So you can just grab it, copy it, and actually run it. So let me just double check. Yeah, we are good. Cool. And here we go. And here you can see we are actually pushing that container. And now what will happen, sorry, that image. I always mix up the two. If I close this, if I hit this refresh button over here, we will see that I now have got my first image inside my repository. And if I go here to the right, we can see that the scan is also complete. So you can see this scan is really quick. Binary package build cannot be stored in ECR like in Docker Hub. I'm not sure I follow 100% exactly what that feature is. You can store the actual image, but it sounds like there might be like binary files that you can store as well, which you can't store in ECR as far as I know. So looking at these vulnerabilities, you can click on it, and what you can see over here is that we don't have any critical, none high, some medium, lows, and informationals. And now what I can do is I can go click on each of these and actually see what they are about and whether or not I want to patch it. Now, things like, for example, GCC. In our case, GCC is a binary that allows us to compile C files. We're not building anything in C. We're not going to be calling GCC. So in our case, we can ignore this. But this is something that depends entirely on what you're running and how you're running your application. But let's get back to the actual image over here. So now we've got our image. Now we want to go, let's say we copy this image, and now we want to deploy it. So let's go back to our Let's Code environment. Now what we need to do is we've got a running version. So now let's see if we can upload and deploy a new version. So let's see, choose a file. So I'm just quickly going to stop my screen here for a second to grab the right file. Just give me a second. Choose the right file, because obviously there are some other files in my directory that I don't want to share at this point. Give me a second. Need to edit that file. Downloads. I'm just grabbing a quick JSON file. Grab it. Cool. Okay. Let's grab that. Image. Edit. Sorry, I'm just literally just editing the file quick. I'll show you all of this just now. And store that. Okay. Docker. Yeah. So basically what I've done now is, there we go. Sorry, I'm just quickly copying. I forgot to create this file. Is minimize this. It's always fun not wanting to share your screen. Let's just do that. Open. Cool. Yeah, I actually have got a terminal. Let me go over here. So what I've been using is a Cloud9 interface, Algebra 97, inside a Let's Code environment. Sorry, a Cloud9 environment that you can see over here. So I've got a terminal. But what I'm doing is I'm just quickly uploading a sample file directly from my machine. So what I did is I created a text file, which looks like this. And we'll go through this quickly. And I just want to deploy it to see what the effect is. So our environment, boom, 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 version label, let's code v1 like that. Cool. Let's say deploy. So it's now saying uploading, deploying version. And now what we can see over here is that it's in the process of updating our environment. So just quickly to show you, if I open up this environment still, this is what the previous version looked like. So this was the sample application that we used when we spun up our environment. So let's just leave that there for a second, because this deployment is going to continue. So what we've done now is we've now done a deployment by hand. And that's never a great idea, because you tend to deploy more than once. When you make changes to your app, you want to be able to deploy it easy. Yes, there's a free tier. If you go to, let me answer that question directly. If you go to aws.com, sorry, aws.amazon.com/free. And what you can do over here is, if you scroll down, you can actually see the different services. So if I go Elastic Beanstalk, no, that's, let's see if let's actually, Beanstalk, just double check. No. Okay. So Beanstalk itself makes use of a whole list of other AWS services. So if you spin up with a single instance, that'll make use of a single EC2 instance. The EC2 free tier, if I look over here, is 750 compute hours of either a T2 micro or a T3 micro. Sorry if it's a little bit dark there with the gray and the difference. Or you can have 750 free minutes of a Windows T2 micro or T3 micro. So we are currently running on a T2 micro, so we are making use of this free tier. And that free tier lasts for 12 months. So always come to this URL, which is aws.amazon.com/free. We'll quickly pop it in the chat here for everyone. It doesn't want to allow. Oh, sorry. Give me a sec. I'm using a screen sharing application, and it doesn't like when I do hop too much. aws.amazon.com/free. There we go. There's the link for everyone. Cool. So what we were busy doing, we were busy waiting for this environment to come up. So let me just refresh and see where we are. Oh, it degraded. What happened? During an abort deployment, some instances may have deployed the new application versions to ensure that they're all working. Cool. So let us see what have we got running, because something broke. well, application is still up and running. So what I think happened here is that my file that I have over here, this one, wasn't defined entirely correctly. So I probably have some kind of syntax error in here. But this just illustrates the point that we don't want to do manual deployments. So how do we go about doing an automated deployment? Well, there's a service called Code Build that allows you to build things. So let's quickly set up Code Build. And for that, I'm going to cheat a little bit because I have a file ready for that, which is the build spec. I'm copying it to this directory. Cool. Now, what the build spec file is the following. So this is a YAML file where we define what the build steps are that we want to take to actually build a container. So let me walk you through these. So the first one is I just want to make sure that I always have the latest version of the AWS CLI. So I'm just doing a forced upgrade of that. Then what I'm doing is I'm echoing some output, firstly, just to see what version I'm dealing with of the AWS CLI, and then also just saying that I'm logging into ECR, because remember, we need to log in always to be able to push to it, which is done via this command. The brackets, round brackets with a dollar means whatever the command is that returns, I will execute. So if I actually take this command as is, and if I run it here locally, let me just quickly bring this up, paste that in. What this gives me is you'll see this very long thing over here that starts up with docker login -user AWS and that -password, this whole long thing over here. That's what the actual login looks like behind the scenes. Then what we're doing is we're creating two environment variables. The first one being the repository that we want to use, which is this account ID along with the region we're running it with ECR. And then also we need to add the repository name over here. So in our case, what we called it was let's code. So we replace that with let's code. Cool. Then what we do is the actual image tag itself. So remember when I look at my Dockerfile and I go to, sorry, where's my repository over here? Over here, we can see that the tag is latest, but I don't want to use latest the whole time. I want to use something unique there. So what we're using is the actual, where's my build spec? Is the actual source version hash. So from our Git repository, that hash that we use, that we're going to use there. So I'm getting that value out of there. And then what's happening as well is that to be able to use Docker inside this build container, we actually have to have the Docker daemon started up. Now that's the Docker process that allows us to send commands to it and then execute them on our behalf. So what this command does is it just makes sure that the Docker daemon is up and running. And over here, we just wait for it for up to 15 seconds just to make sure that it's up and running. So then we know, Docker is up and running. I don't understand the joke there. Let's code. Did I make a mistake? Oh, thank you. Thank you very much. This is why we have our viewers. Well spotted. I would have wasted a lot of time on. Thank you very much. So now we've got the portion where we can build our container, but we haven't actually executed any build commands. And this is where the next part comes in. So over here, what we do is the actual build steps. Now with Code Build, you can have different phases. So the previous one was the pre-build phase. Now we've got the build phase, and we're going to have the post-build phase. Now for the actual build phase, what we do down here is literally we are just echoing some information, which is the timestamp for building and creating the image. And then also lastly, we're going to execute that Docker build command with that specific repository and tag. So that just builds the container like we did locally. So if I go here in the history, let me just find it. So over here, instead of this, what I could have said here is this is where we put that long command. So if I go back to my repository over here, if we look at the push command, so you see over here that I do firstly the build and then I tag it. What I can do is if I say build it -t with, with this long name, it'll automatically tag it with that. So I wouldn't have to run this tag command, which is what we are doing inside our environment over here. So that is what this line 18 does over here. Now for the post build, this is actually where we do some extra steps to actually push our container. So firstly, once again, just echoing out some information and timestamps just to see how long it took. Then we're running that Docker push command and we are pushing it. And then what we have at the end here is that I don't actually need it for this environment. The reason is that if you set that immutable flag to true, if you try and push and that container already exists, it's going to give you an error. Now with Docker, if I rebuild the same commit ID, then I'm going to push that same commit ID, which means it's going to give me that error. By using this double pipe exit 0, this will always be a successful exit, which means I don't have to worry if I've got an error there. But for today, we actually don't need that, so I'm going to remove that. Then what we do is also just quickly the image definition for deployments later. Now, this is where this other file that I showed you. So let me just quickly grab the content up until the end over here. Comes from. So this output that I had over here is now just in a single line with all the values, like I had previously. So let me quickly just take this away. So what this file does is this is what tells Elastic Beanstalk what we want to deploy. So when you look at it, it says that we're deploying an image, and here's the location of the image. And then also that we want to update it true. So it forces us to actually replace the container, always pull the latest as well. And what we want to do is we want to expose port 80 for this. Now, the other part that's interesting up here is this AWS Eb Docker Run version. Now, currently we're running version 1. Now, just very important here, a lot of people get confused when I tell them that if you set it to 1, it means we're running a single container. And if we set it to 2, it means we run more than one container. That doesn't mean that this value is how many copies of the container do I want to run. This is a version of the Docker Run version of Elastic Beanstalk. So version 1 was the built to only run a single container. Version 2 of it runs multiple containers, whether it's 2 or 50. So what you can do is if you set this to 2, you can have multiple container definitions in here, and it'll actually run the containers side by side on the same host. So that's how you would get, for example, that 3-tier architecture we spoke about earlier. We can have one container that's the web service, Nginx, and then another container that's, let's say, your backend running Java, Nginx, whatever it is you want to run. That's how you would do it. So this is all that this file does. So that's, sorry, I want to save this, what that file does. Don't save. It just defines what to deploy for Elastic Beanstalk. So now what we need to do is we need to set up a job that actually can build this for us. So now we head over to the service called code build. That's code commit, which means this will be code build. Let's see, code build. Yes, awesome. But before we can do that, we actually need to commit the file because otherwise we can't access it. Let's just see what we have over here. So we've got a couple of ones missing. Awesome. Git add all of them. Git commit. Let's just say first version of new app. You know, git push, and now our code is inside our source repository. Cool. I'm going to speed up a little bit if I can get to the custom URL at the end. So what we have now is that we want to create a new build project. So we say new build project, and it's going to ask us for the name. So let's just say let's code description. Let's code containers. If I can spell containers, sorry. And what we have here is that we're not going to use the build badge to display. And what we need to do is we need to decide on the source where we get that. Now, default is code commit, but as you can see, you can use S3, GitHub, Bitbucket, GitHub Enterprise. So for us, let's quickly find that repo. There's only one, so it's easy to find. The branch that we want to use is the default one. So let's pick. It's master branch at the moment, not a specific commit ID, and everything else is default. Now down here, the environment that we want to use to actually build our container. What we're going to say is we're going to use the managed image, so the default one. You can also build your own one if you've got some special tools or steps you want to follow. We're not going to be doing that. So we're going to be picking Amazon Linux 2. And then the runtimes that we want to do is we're going to just select the standard one. We don't want anything fancy. And we are going to pick the 64-bit architecture, the latest version of that, because we want to use the standard ones. Environment is Linux. You can also pick one that with a GPU attached to it, which means that if you've got something that needs accelerated compute of some kind using a GPU, you can, but we don't. Then the important part, we are building a Docker container. So if you can see, enable this flag if you want to build the Docker images or want builds to get elevated privileges. So in our case, yep, we definitely want that. So we want to do that. Then what we have to do is we have to give this build job an IAM role to allow it to interact with different services, for example, ECR. So we're going to give it this one. Cool. And we're not going to set any of the other configurations over here. Then we are going to specify a build spec file, and we're not going to change the name because we have that build spec here inside our repo, that build spec.yam. And now we're not going to do any kind of batch or artifacts. We're just going to leave all of these as is and go ahead and say, create the build project. Algebra 97, yes. What we're busy setting up is a job that's connected to our code repository, and I'll show you in the end when we get there that we can actually update that version. So We have got this build job, and now let's say start the build, and we're going to wait for this to kick off. So I have to say, cool, source, boom, 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 boom. I'm just going to hit the start build at the bottom and wait for it to finish. Cool. This will take a few seconds. So to save some time, what I'm going to do next is I'm going to, yes, the build spec file is similar to a Jenkins file. Jenkins file is normally in Groovy or JSON, I believe. Build spec file is in YAML. So yes, it's the actual build steps that are interpreted. So what I'm going to quickly do is I'm going to just jump to the next step, which we're going to do afterwards, which is set up a custom domain. While this is building, we're going to get back to it. So to be able to, oh, I must actually delete this. Let's get rid of that certificate. We don't want to cheat today. So I want to have an SSL certificate to be able to use my service and also attach a custom domain to it. So we're going to say, create us a new certificate. We're going to request a public certificate. And we go ahead and what we say is we want one for, it's developersletscode.com. And also we're going to add an alternative to this, which is www.developersletscode.com. And we're going to request this certificate. And we're going to make use of DNS validation. Quick question, Tusharm. Yes, you can definitely automate all of this with the CDK, which is the Cloud Development Kit. And we can possibly look at that in a few. We actually have that next week. So at the same time next week, we have got a session on the AWS CDK and how to get started with it. This is purely just to show you in the console. So now for the certificate, we are going to make use of DNS validation, which requires us to create some additional DNS records. And this proves to AWS that you own the domain. Because if you can add records to the domain, you're probably in charge of the domain. The other validation method requires you to send an email and click on a link, but that takes too long. We're not going to add any tags, so let's going to say review, and let's go ahead and request these records. Now what's going to happen is in the validation phase. And what you'll see is that there's this the two sections over here. Let's open that up. And it's going to ask me to create a record that allows it to validate. So let's go ahead and say create. And let's go ahead and say create. So we need two different DNS records to validate the two portions of it, because this could also be a completely different domain. In our case, it's the same domain, which is developersletscode.com, but it's the www versus the non-www version. So this will probably take a few minutes to do. So let's go back to our code build job over here. So our build successfully started. It ran. It said pre-build state failed. Error executing this. Reasons 255. Now this is because the role that we have is not allowed to interact with ECR. So we need to go fix that quickly. So let's go to IAM. Go to our job over here. I'm going to look for that role. It's something with, let's just get this out of the way. Developers, let's code. Let's see what it has. So the permissions this one has is, if I open this up, let's take a look. JSON, loading. It allows us to create logs, create a log group, put files on S3, allows us to interact with a specific code commit repo, git pull, does code build, and nothing else. So this is interesting. So it doesn't have access to actually interact with ECR. So what we want to do is we want to give it an access to that. So I'm just going to, for now, for the sake of speed, I'm going to pick ECR over here. Sorry. Is it container? Yes. So Amazon EC2 container registry full access, because I wanted to be able to create and tag and push containers. So let's say attach policy quickly. What you would do is on a per build job is you would limit this to only be able to access that one specific resource. So let's go back to our code build job over here. And now what we're going to be doing is we're going to say, let us retry this build and give it a second. And while this is going, we're going to multitask and jump back to our certificate over here. Let's see if it's been validated. Okay, so it's still pending validation. Developers, let's code. Developers, let's code. Sorry, I'm just checking that I didn't make a typo over here. Let's just check. Interesting. So no, pending, refresh. Cool. So it's currently still running. We might not be able to get to that point because we have got 4 minutes left. So our build over here, it is almost kicking off. There we go. Let's keep an eye on it while I have some more water. Cool, it's busy running. Now it's running that, and we passed that point. So now all of a sudden we can log into ECR because we gave our build job permission to do that. It's now running the actual build, all of the steps, and what it says that it has completed. So if I go back to my not code commit, let's close this. Where is ECR? If I close this and if I refresh this, what we'll see over here is we now have 2 versions. Awesome, we've got a new version. Now the question becomes, how do we deploy this? Because we now have the ability to automatically build our container. We want to now get it in front of our users, because obviously this is a version that people think, well, someone's just running a demo. It's not really working. We want to get our production side out there. So what we're going to do for that is we need to set up a code pipeline job. That's a mechanism to string together multiple different steps to form a pipeline that ultimately ends up with deployment. So how do we do that? We say create pipeline. And once again, we give it a name saying let's code, Elastic Beanstalk. Cool. And we are going to create a new service role. And you can see it'll create this nice long name over here for us. And we are going to allow AWS Code Pipeline to create a service role that can be used for this. We're not going to mess with the advanced settings for now. We're going to say next. Source provider is going to be code commit, because this is what actually triggers the pipeline. So now what we do is over here, what you'll see is it's going to ask us for the actual repo. We'll pick it. We'll pick our branch. And then what happens is it'll actually use CloudWatch events to automatically detect any version changes. So let's go ahead and say next. Build provider, AWS code build. It'll pick up that project that we previously set up. And we're just going to do a single build, and we're going to go to next. And now this is where the fun comes in. We're going to say deploy. And this normally is quite a headache where you've got multiple steps. You have to have config files, some bash scripts, some funky things to get your stuff out. But we are using Elastic Beanstalk, which means we select Elastic Beanstalk. It asks us what app do we want to deploy. Let's code. What environment do we want to deploy? That environment. And we say next. Now we review all of the settings and we just go ahead and say, boom, create our pipeline, please. And what will happen now is it'll actually use all the configs. Now, that single little text file we created in our build step over here, this one. Let me just open it up again. Not new terminal, sorry. Close. New file. If I paste this in here. So remember that little bit of JSON over here that defines the image and the ports. Sorry, and the ports over here that we are running on. So we're literally giving it that container name and running on a specific port. That's all we're passing to Elastic Beanstalk. So now if I go to my code pipeline over here, we can see that it's already kicked off the pipeline. So it's checked out the source code from our repo. Now it's busy running our build. Now this will obviously take a few seconds, and we are just going to wait for that to complete quickly. I realize that we're hitting the hour. Yes, so once again, Algebra, all of this can be done with various automation ways. You can actually use the AWS CDK to do it. You can use CloudFormation. You can use Terraform. There are a lot of ways of doing it. The purpose of today's show is to just show you the easiest way to get started, which is just quickly clicking around the console just to get a sample application up and running. So let's quickly click. Let's get that out of the way. Let's just refresh the page to see how far we are. This usually auto updates, just want to make sure that I didn't press escape on the page or something to stop it. Okay, cool. So the build succeeded. Now we're on the deployment phase. Now let's hop to our let's code environment quickly and refresh this. Now what we can see over here is like, ooh, there's a deployment underway. So this is where things get excited or exciting. I'm just quickly thinking, I don't think we've got another show on this channel, so I'm going to continue with this for a few more minutes for those that are able to stick around. What we have is that over here we can see the logs. Those errors were the previous version that actually didn't work the way I expected with that file that I uploaded. I probably had some kind of typo or some kind of mistake in there. This version, however, is using our code pipeline, our code build job. So this should work. So if I go to this page now, let me see if I refresh. Okay, so this is still the old version. So we're now waiting for it to actually deploy that. So we're going to wait for a few minutes. It's fairly quick usually, but I don't want to waste time. So I'm going to jump back to our SSL certificate. So let's see if it's validated yet. Oh, yes. Awesome. So what do we have here? We have got an issued SSL certificate that we can start using. Now, if I go back to my environment over here, let's quickly refresh that. It's still in the process of deployment. If I refresh this over here, it's definitely still the same container over there. Let's see. Oh, it failed. Deploy the new application version. Ensure all instances are the same version. Redeploy. So it doesn't like our deployment. So I've made a mistake somewhere. It could possibly with my configuration. So let's quickly dive into Elastic Beanstalk's configuration and just see what we have over here. So we've got a specific instance enabled, container default. Let's see the capacity, min, max in, it's load balance. Yep. Okay. So we've got our load balance version, availability zones, network out. Cool. All of these configurations look good. The actual environment is still the same. I have a mistake somewhere in my configuration file, I believe. Let me just double check. Application versions. Let's see. Build artifact. That seems right. That's the file that I uploaded that didn't want to work. Let's just look at the source, what this file is. I'm just quickly going to open up the zip. Give me a second. This is a Docker Run. Sorry, it's just off screen at the moment for a second. I'll bring it up in a second. Nope, it wants to open it. There we go. Sorry, give me a second. Ooh, text editor. That's normally good. Cool. So what we have over here is that this is what our build file looks like. Let's replace all of this over here. Update, image. Cool. So it is going to be deploying this. So what am I doing wrong? Let us quickly dig. It might be because I've got that sample application running. My gut feel tells me that there's some setting there that I missed. So let's quickly dig into this and actually take a look at what this file looks like. It takes us to that sample application, Docker zip. Let's open this up because I want to see what this config is. Like I said, I'm 99% certain I made a mistake in here. Yes. Let me just open this up with text edit as well. Okay. So the way this is set up, let me just get to my console over here, is when I look at that run file, what it looks like is this, which is Docker version 1. It's got logging. It doesn't use an image and doesn't update. So I think this is something to do with the way that it's currently running. So let's quickly see if I can fix this. Actually, you know what? I believe it's because of ECR permissions. So let's quickly look at that first, because that'll be my first port of call now in terms of figuring it out. Also, Tashar, yes, debugging. Part of the show is to show you how to figure things out. So that's why, while it is scripted in the sense that I've got a list of things I want to cover today, and I do make sure that I roughly know how all of these things work, I don't want to give you a fully polished, never make a mistake version, because that's not how you learn. Because often you'll run into these types of problems. So, for example, our code build job that failed. So this time I think it's the same. It's the IAM permissions. So let's quickly look at our Beanstalk environment. Let's go to environment. Let's take a look at our configuration. And let's search for IAM. Sorry, IAM over here. Aha. We have got Elastic Beanstalk, this one, right. Okay, service role. Right, so we are going to go back to IAM over here. Let's look for roles, EC2. That was Elastic Beanstalk. Yes, it's that one. And if I look at the permissions over here, Beanstalk multi-container. Let's just see what the permissions in here are. ECS, start task, discover, deregister, register, submit. This doesn't allow you to pull. Next one, worker tier. Sorry, scrolling is a bit. It allows DynamoDB, logs. Cool. It is what I think it is, which is it does not have the ability to actually pull our container. So let's go ahead and say container. And this time what I'm doing is I'm not giving it full access because we only need to pull containers. So registry, read only. That should be sufficient. Attached policy. Cool. Now what I'm going to do is I'm going to go back to our environment over here. I'm going to, our code pipeline. I'm going to say retry. 99% certain this is our issue. So how it works is that the EC2 instance in the background actually has a IAM policy attached to it via the IAM role. And that's similar to other services like our code build job, where we give it a set of permissions, because by default, it doesn't have any permission. So it literally can't do anything, because imagine having a virtual machine inside your AWS account that can just call things and do things, delete permissions, add permissions, opens up ports. I mean, that's a massive security risk. So how it works is that there is this concept of IAM policies and roles, and you define what the server is able to do. Now, in our case, we didn't have the ability to pull from ECR, because that's a privilege that we didn't assign to it. So now what we're doing, we are now just rerunning the deployment phase. So if I go back to my application over here, let's click on application, let's go to let's code, environment. What we can see over here is that we now have got the deployment that's busy running. We can see here is saying deploying new version to instances. Now let's just quickly see, maybe it's replaced it. Oh, yes, it has. Do you see what's happening here? We now have our awesome application running. And as you can see, this is the one that's going to get us the money on those users. Because I mean, where have you seen a site that's this slick? Just kidding. My HTML skills are terrible. But we now know that our container is up and running. So we are happy. Awesome algebra. Just quickly, if you are interested, we actually have a number of streaming sessions running at the moment. I don't know what time zone you are in, but this Let's Code session runs every single Wednesday going forward now in this time gap. It's currently an hour slot. We might extend it to an hour and a half or 2 hours. I'll ask and see what we can do there. Then also, 2 hours before this, we've got an EMEA-wide Ask Me Anything session where you can come up and ask us any AWS questions. Then we also on Monday and Fridays at 3 hours ago, I'm not sure what time zone you're on, but Central Eastern Time, we'll set up Central European Time at 11 a.m. On Mondays and Fridays, myself and Darko Mezarosh code things with CDK. So you're welcome to drop in. Everything all runs on the AWS Twitch channel, so feel free to drop in there. But okay, getting back to our app. So deployment succeeded. We are healthy. We are good to go. Sweet. Let's just confirm quickly by clicking this link. Sorry, there we go. So we have our thing up and running. Almost pronounced my last name, Mezrosh. Sorry, my tongue is lazy today. Okay, but once again, we still have one more problem. This URL is not nice. How do we fix it? Well, the first thing we have to do is we have to actually take our application and scale it. So let's configure it, because we want to make use of a load balancer. So let's just say instances over here. Let's just double check, sorry, configuration. Yeah, configuration. Instances, we've got 1 at the moment, capacity 1 to 5. Okay, oh, so we actually already have a load balancer. That is awesome. So let's go ahead and actually edit this load balancer. We're listening on port 80. So what we want to do first is we want to be able to add another action. So let's add over here. What we say, this is HTTPS, and this is not on port 80. This is on port 403. This is going to run on HTTPS. Health check, check. It should ask me for a certificate. Let's just make sure. Yeah, HTTPS. Yeah. Validating environment thing, pending create. Port is there. Oh, sorry. I am not paying attention. This is the process. Let's remove. Mark is removed. Sorry. What I want to do here is add a listener. That's interesting why it didn't ask me for the SSL certificate. This is HTTPS, which now asks us for an SSL certificate, which is la-di-da, that one we created. And now we have got an SSL or SSL policy we want to apply. I'm just going to grab the first one quickly, just to get things going. And we're going to route traffic to the default process. Now, this is where things get interesting, because I could have had multiple containers running on different ports. And then by adding that second process, I can expose that port and then have traffic routed to that port. So let's go ahead and just say add this. And now what it's doing is that, okay, it's pending the create. So this will take a little bit of time to do. So now the last bit that we have to do is we have to add a CNAME record to actually access our environment. So let's see if we can get to that configuration. If I go over here, yep, apply, done, cool. It should be in this configuration setting somewhere. Awesome. Guru Kathril, sorry, I'm struggling to pronounce that name. Guru Kathirivil. Glad you're learning something. We've got multiple streaming sessions, like I said, per week at the moment. So definitely keep an eye out. We are here to help you learn how to use AWS and also play with new things. And like I said, this session is running every week going forward. And also Mondays and Fridays at 11 a.m. Central European time. Dark and myself are coding. On Wednesdays, 11 a.m. Central European time, we've got an Ask Me Anything session. On Thursdays at 12 Central European time, I've got the AWS Africa office hours, but similar to other sessions, please drop in and ask us questions. I would highly recommend following me on Twitter. Let me quickly put up the banner for that. There we go. So there you can get my details for both Twitter and LinkedIn, and keep an eye there on when I publish about when we are going online again. So what's happening now? We are busy changing our environment, adding that value to our load balancer over here. So let's quickly go back to our configuration over here and see if we can find anything about our the URL we want to use. That is probably under our load balancer. Let's just double check over here. That's rules, default. Let us see if I can actually just, if I go to EC2 over here, I believe. Just keep an eye here on the comments, sorry. Let's see if I can see the load balancer. I don't think it's here because it's a managed environment. Oh, it is actually awesome. That makes it a bit easier. So DNS name, I copy that. And now what I do is I go to route 53, which is a DNS service. So what we can do over here is that I can create I've created a hosted zone, which manages our developers Let's Code domain, which we can see over here. Let's click on it. Let's get rid of this message up here. And what we can see is, remember those records I spoke about that validates the SSL certificate? Well, they are these two records that automatically were added by just clicking that Add to Route 53 button we saw in the certificate console. Then we also have our name servers, which are these ones, and then also our SOA, service origin authority, service of authority. You can remember that's just something to do with where the DNS starts. Out of my mind at the moment. So what we want to do is we want to create a record to get to our application, because let's just keep an eye here. Okay, so it's actually deployed. Cool. So now we've got this, and what I can do is I can go HTTPS and hit that. Now we're going to get a warning in the browser. This is expected because what we can see over here is if I look at this details, what it tells me is that this server could not prove that it is Let's Code bloody, which is this long URL that we have up here. Its security certificate is from developersletscode.com, which is what we want, which means that we've got the correct certificate being issued, but we don't have the right DNS name. But we can still go ahead and say, proceed to the site. And now at least we're running on HTTPS, but it's not the right cert, so it's still not secure. Christopher, past episodes with structured time arcs. I don't think we've got structured time arcs yet, but I will put that on the list to do. But we do have the episodes available. Let me quickly find it. YouTube, John Rotenstein, I believe is his surname. Sorry. Rotenstein, yep. Here we go. I'm just going to quickly not start the video, but I'm going to go to CQ John. And if you look on his page, so let me see playlists. You should have a developer Let's Code. Yes, here we go. Developers Let's Code. Let's pause this again. I'll grab this. Let me share you. Sorry. Let's try and copy forcibly. Paste. Yes, there we go. Cool. So what you can see over there, when I send that is the link to the playlist with all the previous episodes. Cool. So what we were busy doing here in Route 53 over here, I need to copy that again, sorry. Boom. Copy is to create a CNAME record for our load balancers. So we're going to say, cool, where were we? Sorry, hosted zone, go away, developers, let's code. And we want to create a record. This is a simple routing. Next. And define a simple record. This is, we're going to use the apex, so we're not going to have any prefix. Choose endpoint. Now over here, what we have is, if I scroll down on this list, alias to a application classing load balancer. Choose region, EU Ireland. So this is where we are running, and choose the load balancer. Boom. There we have our load balancer. Let me just double check. I just want to make 100% certain this is the right load balancer. Elastic load balancing, Elastic Beanstalk. Yes, we have got the right one. Awesome. So let's go back over here. So we leave everything else as is, and we say define that simple record, and we say create record. Now what I'm going to do is I'm going to create a second record quickly, also a simple record, and this is for the www version. There are ways to do redirects. We're not going to be looking at that today, unfortunately. So once again, we say define a simple record, www, and we're going to choose an endpoint again is load balancer, classic or application. Region is EU West 1, which is Ireland. And then what we do is we choose our load balancer again. So similar to before, same thing, we say define the record. Cool, create record. Now what we can see over here is if I clean this up, is if I scroll down, we have got an A record for developers let's code, as well as a www.developers let's code. Let's quickly see. Okay, let's see if this is up running. So let's dig developers let's code.com and see if it is up. So dig is a command that allows you to do network lookups. So I'm getting excited. I think this is already configured. Let's see. Is our awesome site up? https:/developersletscode.com, and you are welcome to do it from your side as well. And voila, we have got our application up and running. And this time, this little block over here shows you that we are running on SSL. And now, just to quickly wrap things up, to just prove that we are not faking things, don't save. I want to open up the index, and let's just say it, our awesome applications v2. So that's the single change. Get status, get diff. We can see that it's literally that v2 that I added. So get add, get commit, v2 that will bring the big money. Cool. And now I'll go git push. So now code pipeline. Let's keep an eye on this. You can let me just quickly refresh. Sorry. What you'll see now is that if I go to pipelines over here, give it a second. There we go. You saw that it was in progress, and over here we can see that the code is already checked out. It's already in the build stage at the moment, busy building, and this will now take a few seconds to complete. And then once that is completed, it'll actually deploy it to our Elastic Beanstalk environment. Now, one more thing to cover here quickly. You saw me issue that AWS certificate over here, this developer let's code certificate. The cost of using the certificate is a whopping $0. These certs are free. This is a very, very big bonus. Now, there is a caveat to it. The caveat being that this is not like when you purchase a certificate from a company and they send you the public and the private file and you install it on a web server somewhere. No, this certificate, it still uses that same mechanism in the background, but we handle those files for you. And we install it on the different services. So you don't actually get access to those individual files and have to deal with them. We can just install them on load balancers or API gateways and actually use them that way. So when you saw me create that listener inside Elastic Beanstalk is how I attach the certificate from a dropdown onto that load balancer so it can start using that certificate. And literally is that simple and that easy to use. And like I said, this doesn't cost you anything, which is awesome. And also remember, we are currently running on a T2 micro, which means that part is also free. So the only part of today, what I've showed you that actually costs money is the load balancer. But let's just quickly double check if that is true, because I actually don't know offhand if we get free load balancer time. So let's say load balancer. Okay, let's Google AWS Elastic application load balancer, and we can quickly look at the pricing. Yes, Elastic load balancing. We can go to the pricing, and let's take a look at. Let's see if there's free on this page. Here we go. First 10 rules are free. That doesn't help us. Okay, so the load balance itself does have an hourly charge of it. That it doesn't seem like there's a free tier for this, unfortunately. It works out to thumb suck about $15 a month if you want to use an application load balancer for it. But while I was entertaining you with that, our deployment, let's just confirm, completed. if I go to our code pipeline over here, we can see build completed, deploy completed. Let's code environment. This one is a newer version. I can also see in, let's just jump back to ECR, container, registry. Just want to show you that we now have one more version. Let's code. Boom, there we go. We've got more versions available now. And now ultimately our website, when I refresh it, guess what? We have got version 2 deployed. So perfect. We have got an entire app up and running, and with a lot of getting distracted by interesting questions and discussions with the people joining today, we were able to get this up in 1 hour and 22 minutes with a lot of clicking. So I hope you found this useful. Please let me know if this was entertaining, entertaining and educational. We like to combine the two. And if there's anything you'd like us to focus on in the future, because what this series is about is literally for people that are new to AWS who want to learn how to use things. And we want to build a journey for them to learn specific things that they can start stringing together to get their first application up and running out there. So please connect with us. Please let us know what it is that you would like us to cover and what else you want to see in future. Because like I said, we're running this on a weekly cadence now. And we will be doing more sessions. For example, next week will be Darko Mestarosh. I hope that's better. And he will be talking to us about the AWS CDK. But you don't have to wait till next week. Tomorrow at 12 Central European time, you can actually come join for a session where you can ask me questions along with some colleagues on the Twitch channel. Dark, I'm fairly certain, will be there as well. Friday at 11 Central European time, you can join Darko and myself where we code with AWS CDK if you want to learn more about that. So please come join us. Okay, so questions quickly. From Frag0, how to configure always use HTTPS. So there are a couple of ways to do that. Firstly, what you do is that your load balancer needs to listen on port 80. And what it needs to do is it needs to have a mechanism to do a redirect. Now, we actually just covered that in our CDK building adventures in our Bean streaming session with Darko. So we did that. What you have is a little Lambda, and all that the Lambda does is it gets a request and then changes the response to a 301 HTTP status code, which is permanent redirect, and then sends the HTTP. So what happens is a request comes in on port 80. It builds up the response that says, listen, the site has moved. It's now an HTTPS URL. And then sends that back to the browser. The browser says, oh, a 301, let me go to the HTTPS version. There are also some other ways where you can register sites, and the browser should know that it automatically goes to HTTPS, not HTTP, but that redirect is normally the easiest one. Come join us tomorrow, and we can quickly show you the code of how that is done. But that, I think, is it for today. So thank you very much for joining. I hope you found this useful, and I'm going to say goodbye now. But actually, it's 25 past. Let me take 5 minutes. Throw me some more questions if anybody has them. So first comment over here is that it's useful. Every software developer should know this. This is something that I agree with wholeheartedly. There are not enough software developers out there that actually know how to get their code out and how to make their code run. They love writing features, building new things, but when it comes to building and getting it up and running, they don't always know how to do that. And the good news here is that there are so many tools nowadays to make it easy. I mean, you saw how I did this with Elastic Beanstalk. There are ways that you can do it with, for example, if you go to the serverless world where you just write code and you don't even have servers to worry about, that you can do it. Look at AWS Amplify for that. Look at SAM, which is our serverless application model, to actually go build those. Cool. Those files that I used, let me quickly think. Yes, the actual files. Give me a second. GitHub. GitHub/.com/ there we go. Cobus Bernard. So I'm very easy to find on the internet. Nobody shares my name so far. So if you go to my repositories, what you can see is there is one. Let's search for containers. It's this webinar containers one. And when you look at this, what you will see is that this is just a different version of that fancy index file that I have. You can see my HTML skills have not improved, unfortunately. So you can see the actual, and this one got up to version 4, which is like hardcore. The actual Dockerfile is there, and also the actual build spec. Now, what you'll see in this build spec is one difference to the previous one, which is that there's line 26 and 27, those two, sorry, 25 and 26, creates another file called image definition.json. It won't affect what we did today because that's just an initial way to define what it is that we want to run. And that file you can actually use in code pipeline to deploy to an ECS cluster, which is just, it's a different service that allows you to run containers as well. So that's just why that one changes there. But everything else that you see here is literally inside this file. With a caveat, you need to worry about your account ID because it needs to match the account that you're building on and needs to match the actual repository. Oh, I'm sorry. I did it again. Here we go. Let's do this again. So GitHub. Open it in a new tab. Go to my GitHub, Cobus Bernard, one word. Then under repositories, sorry, it's in the corner of my eye, I didn't see the screen. Then search for a repository just containing the word container. You'll see there's one that says webinar containers. And if you open this one up, this is exactly what we did today with a slightly different website content. So my joke fell flat because guess what? You couldn't see that this is version 4, which is the awesome one that makes all the money. And inside here, what we have is the actual build spec file as well as the Docker file. And if you go into the build spec file, the only change here that you have to make is that you need to swap out your account ID. You need to change your ECR repo depending on what you named it. And then also the part that I was talking about that you obviously missed because I didn't show it on screen is these two lines. So you can see over here, I'm doing the same as I did with the Elastic Beanstalk version of how to build up that file to actually deploy. This version of the file, which you can see, it looks similar, but it doesn't have this runtime version embedded in it or the image sub node inside your JSON document. This bit of text allows you to deploy directly to an ECS cluster, which we'll do hopefully at some other point. And then lastly, also you have the artifacts. I actually didn't cover that, apologies, which is I tell the build job that this file that I just created as part of this build exposes it as an artifact for other servers to be able to grab and make use of it. And for Elastic Beanstalk, this is the default name of the file, so I don't have to configure anything. If it sees that file, it knows how to deploy that file or use that file to deploy. Cool. So what I'll do quickly is I will paste. Can I not paste anymore? Sorry, there we go. I will send that through. Oh, it's not everything. Let's just make 100% sure I copy this. Copy. Sorry, the reason this is a little bit difficult for me, there you go, is that I have got two different workstations. This is my work laptop running macOS. And over there is a Windows machine that's handling all the streaming for me. And I'm doing an interesting screen share situation. So copying it between the two, I've got a keyboard sharing application called Synergy. And the copy and paste is a little bit confused at the moment because I was fiddling with things. And unlike last week, I didn't do a reboot this time because I was too scared things are going to break. Because last week I started a reboot and there was a patch and I started the session with nothing open. So we are now on the dot half past. So I'm going to say thank you very much again for joining today. If you have any follow-up questions, please reach out on LinkedIn or Twitter. I'd love to help you with your things that you're building or tell me what you want to see next. And with that, I'm going to end the broadcast. Hope you enjoyed this. Bye.